Alright guys, this week I was going to do chapter 5, but after getting into it, there's so much, I guess, ideas and concepts in chapter 5 that really need a thorough explanation. I could either do a 2-hour lecture on chapter 5 or kind of break it up into two parts. So first, I just want to kind of like go over the basics of player movement, the basics of a script, and some stuff in Unity. And then next week we'll go into Chapter 5 and we'll write our script for our player in the game that we're making. So, when you start building your game, you start with the core. Think about what your game is going to be focused on. Is it a PvP game? Is it a first-person shooter like Call of Duty? Is it a puzzle game? Things like that. And you design the core first. If the core game doesn't work, your game's not going to work. So in a first-person shooter, we mentioned it was combat, but in a 2D platform game, typically movement is the core of the game. So you want to focus on that movement. Like if you look at Super Meat Boy, or well, let's start with that. He sticks to the wall, and he can actually just run up, one straight wall. He doesn't need two walls to jump between. So movement was a key focus. So for our 2D platformer game, we're going to focus on movement. Now, in Unity, Unity supports 3 scripting languages, and really it depends on what your plans are for the future. Boo, and it still supports Boo, and I don't really know anything about Boo. Actually, I never even heard about it until I read it in this book. C#, and then JavaScript. So C# and JavaScript are really the 2 big ones. C# is gaining a lot of popularity in social media, gaming, web apps, things like that. Where C# is still like a mainstay in business. Like I have a friend that works for Infocision, and they're the company that owns like the Cleveland Brown Stadium, stuff like that. And all of their apps are coded in C#, so he's a C# coder. So it all depends. I mean, if you're just going to focus on games and maybe social media and stuff like that, you probably want to get into some JavaScript. If you also want to be able to get jobs as just a software developer and a gamer, you might want to do C#. But we're going to focus on C# in this class. Alright, and then Unity's IDE, Independent Development Environment, is called MonoDevelop. So whenever you go to create a script, you'll open up MonoDevelop, and then you'll code that. That's where you'll code your script. So that's what Unity uses. So at this point in our game, we've created a player, but it just links to a sprite and it doesn't do anything. You could throw any sprite in there right now, and you could still have the exact same thing. You just have a graphic that kind of sits there. So we need to link that to some code, and then the code will tell Unity how to make it move, how fast it'll move, how high it can jump. As it's jumping in the air, can he change directions, things like that. And we typically call this the character controller. Although you'll also hear it called the player controller and some other names. So when we're talking about movement, your book in Chapter 5 talks about 3 distinct areas. Movement style, and there's discrete and smooth. And I don't think anybody uses discrete movement anymore. With discrete movement, your player was always centered on a tile. So he was always at the center of a tile, and he moved between centers of tiles. So it wasn't a very smooth movement. It was kind of clunky. So then we obviously graduated to smooth movements, and then now the player can be located on 2 tiles, so he can kind of like move smoothly across the screen. So that's what we've seen, and actually pretty much for most of us, that's all we've seen in our lives. Alright, then acceleration. Slower acceleration means less precision in player handling. So it all depends on what kind of game you're making. If you're making a platformer game where you have to jump to certain things, you typically want faster acceleration so you can be more precise in your landing. And then your book talks about air control. When I jump, can I control the player in the air? Can I turn around? Can I change directions? Like if you've ever played TF2, the scout can double jump, and he can actually, jump forward and then jump to the left and like avoid something. So it's kind of cool. So make sure you're good with those, and you've got those areas kind of highlighted in your book, because those are going to make perfect, good quiz and exam questions. All right, real versus fun. Realistic physics are great. People are like, oh, this game is real. It's the closest thing you can get to blah, blah, blah. But sometimes realism takes away from the fun and kind of makes for a boring game. Imagine if COD, Call of Duty, didn't have bunny hopping or dolphin diving. So your number one concern when you're creating a game is, does it invoke the emotional response I wanted it to? So realism is okay, but fun is always better. Fun will always net you more players than realism. If you can make the core of your game fun, doesn't matter anything else. Your graphics can suck, the story can suck, but if the core game is fun, people will play it. And that's really the whole kind of thing about Minecraft. Minecraft was fun to create things. Shitty graphics, I'm sorry, bad graphics, pardon me about my French. So bad graphics, nothing to do, like they didn't plan out any quests or nothing. It's just here's you, go mine some blocks. But because it was so fun creatively, it was huge. Alright, if you don't know what bunny hopping is, here's a quick video. Some people hate bunny hopping, some people love it.
Okay.
Destroy the objective.
No.
Now you see this guy jumping all around like they're bunnies.
Oh.
This was not an original mechanic that they thought about when they first created Call of Duty.
Oh my god. I did not. I did not just do that. Dude, I'm sending that to MOG.tv.
Alright, so basically, that wasn't built into Call of Duty, but players started doing it, and some of the really better players started doing it more, and it became a thing. And then I'll say everybody started doing it, but some servers banned it, and they actually disabled the jump key. Other servers promoted it, but bunny hopping was a big feature of the game that was not designed into the game. Alright, dolphin diving, another feature that was not intentionally put into shooter games. Again, some people hate dolphin diving, some people love it.
Hey guys, Drifter here. Today I've got a funnier in-depth for you on dolphin diving in Advanced Warfare. Yes, some pro players have figured out how to dolphin dive in this game, and I'm going to teach you how to do it today. I wouldn't say it's the most useful thing, or the most practical, or that it's really even a big bug or a big deal, but it certainly is funny. No more wasting your time, let's skip right into the dolphin diving. I did this on split screen on PlayStation 4. I did find it a little bit easier to do on Xbox One for whatever reason, but I recorded on PlayStation 4 for the 1080p. The steps to do it are pretty simple, but you have to get the timing just right or it won't work. What you need to do is boost slide, and right in the middle of the fastest point of your boost slide, turn right or left as fast as you can, and this will force your character to prone. The very instant you go prone, jump, and you will do a little dolphin dive type maneuver. It really looks more like spinning or free falling or something, but that's how you do it. Ways to screw up: if you try to just
Alright, so dolphin diving is basically people would jump around corners and then go prone as they were jumping in the air. So instead of seeing a full body, you would only see, somebody laying down, but so like you couldn't hit their like at the bottom or the top. So it was a way to make your hitbox smaller coming around corners. So again, some people loved it, some people hated it, but it was fun in a lot of games, and it was a feature that was not necessarily designed into games at the beginning. So think about stuff like that, and like when you're designing a game, what's going to separate you from everybody else? If you make a first-person shooter, what's going to be different about yours that hasn't been done before? All right, so now here's the point where we get away from the book. On chapter 5 of the book, they walk you through a script, you pop it in, and then all of a sudden, boom, your character can move. But anybody can copy a script, and honestly, especially for beginning gamers or game design people, there's a lot of scripts out there. If you need help, coding the enemy movement or the AI or something like that, there's a lot of scripts where people were like, oh, hey, there's a script here, and you just kind of like pop it in, and you have no idea how it did it, but you can just copy it and move it. So that's fine when you're beginning, but some things you need to start picking up because eventually you need to start designing your own because you're not going to be able to find a script that does exactly what you want. Alright, never mind this thing at the bottom because I'm going to create that for next week's video. So I want to get away from the book. I just want to focus on making a player move and going through the different components in Unity that allow that to happen. So at this point I want you to open up Unity and create a 2D test project. You can name it Trashmere or whatever because you're going to delete it at the end of class or at the end when you're done. And then we'll kind of go from there. Alright, I got Unity open. I got a 2D game, but the first thing I want you to do is go here and make it 3D. Even though I just wanted you to kind of see, like, if you make a 2D game, you always start like that, and any graphics you import will be sprites. But then I can go to 3D just like that. We're gonna do like a 2D isometric game, or a 2D isometric stuff, so we can kind of see what's going on. All right, now I want you to go to Game Object up here. We're gonna create two game objects. The first one, we're gonna hit Game Object 3D, and we're gonna create a plane. Now, a plane is just a surface we can walk on, or just a flat surface. And then once you create that, you'll see it on the floor. I can click away, and then you want to go back and do 2D, 3D object, and now we want a cube. So your screen should look like that. And if I click off of it, now I can even see my cube. So if I click on cube, then I can kind of see the transition tool on there, so I can kind of have an idea where it is. But that's the first two things: make the plane and make the cube. All right, now I need to make it so I can see it a little bit better, because again, if I click off of that, it's like, where'd my cube go? So I want you to go to Game Object, and then click on Light, and then do Directional Light. And we're going to make a light source. Once we have our light source on there, we're going to go to maybe the hand tool and click on Directional Light, and I need the Rect tool, or wait a minute, I need the Transition tool on my light. Hold on, come here. You come here. Hold on, let me figure this out. Dope. Alright, and actually it starts on the middle, so I do want to do my directional stuff. And actually this is the light. So if I grab the Z and move it, now I can kind of like have it there. And then I can grab that, move down, that, move over. And then I can grab my screen, rotate. Okay. So I'm good. So that's what you want to do. To me, when I first clicked on that, it looked like the transition tool was on the cube, but it was actually, everything's going to be centered here. So when you create something new, you got to drag it off. So if you can't find it, click on Directional Light, and then click on the Transition tool, and then grab the Z axis and kind of move it over to the side. And what we're going to do is we're going to project a light this way, so now I can kind of see my cube. And now go to your cube, and with this Transition tool done, and let's bring him up, and now we can kind of see him too. So now I can see my full cube, I got my light source, I'm all good. So lighting is very important to a game. You know, you can now that you can click on Directional Light, you can make the intensity brighter, less bright, things like that. Later on in the text, we have a full chapter on light, so I'm not going to go into that too much now. But our scene still looks ugly. So we're going to try to fix it by adding some materials or some textures. So go down here to the Asset folder. I'm sorry, the Project pane. And you're going to click on Create here. So right underneath Project, click on Create. And then you're going to create a material. And we're going to call that first material Cube. And then you're going to do it again. Create Material. And we're going to call this one Plane, which is going to be our floor. So if everything went well, you should have two of the exact same kind of materials, one called Cube, one called Plane. Now we're going to associate the cube material with the cube game object. So we're going to grab the cube material and we're going to drag it to cube. And you can look at the mouse, how it's got the circle thing. And I can put it on cube. I don't want to put it here between cube or underneath cube. I want to put it on cube. I want to make it a child of cube. Boom. So now when I click on cube, I can see that texture there. And then you want to do the same thing with plane. Grab plane, go to the plane, make sure it's highlighted like that, and then let go. Now if I click on plane, he's got his texture or his material. If for some reason you can't see the screen, like when I show you what the highlight looks like, go to slide 16, and that will show you a screenshot of that. Alright, so assuming you did everything right, go back here and click on Cube down here in the Project window, or the Project pane, and look for this little thing right here. If you click in here, you can now change the color, and I'm going to have a bright red cube. And if I go to plane, I can now go in here and change the color of the plane. Give me some blues. Ooh, I can see that nice and clear. Let's make it stand out a little bit. And that doesn't quite look right. That's good enough. So you can change the color. Now I can clearly see, where the plane is and where the cube is. So now you can see a lot of these game objects and 3D models are just outlines or polygons, and where they're just the lines that kind of cover the angles. And then you put a material over those, and then you can actually put a texture over those. And that's what actually gives it the color and the look and the feel of different things. Now we're going to do one more thing. We're going to click on directional light. And we're going to go over here to the right and do soft shadows. And now when we move our game object, you can see we now have shadows. So once we're done and we can move this cube around on the plane, we'll be able to see the shadow and how it changes, in relationship to the angle of the light source. But it'll also help us to see movement a lot better. Alright, so now we're going to create a new folder. And you can do this a lot of different ways. I'm just going to right click on Assets, Create, New Folder. And this is going to be Scripts. And I can even do another one, create new folder, and call this materials. And then I can grab the materials and drag them to the materials folder. But everything is still the same. As you're working on a game, it's okay to have a bunch of assets and crap all over the place. But eventually, at some point, you need to organize that stuff. So now you know how to do that. Now, we want to create a new script. So you're going to go to Scripts, right-click, Create, because we want to create it inside that script folder. If you do it in Assets, it'll create it just in the Asset folder. And you're going to create a new C# script. So wherever you click, that's where that object will be. And now I'm going to rename this to Player. Now you see over here on the right, anytime you create a new script, you get this basic thing. Unity creates the class and it uses mono behavior, and then you get void start function and then the void update function. And if I double click the player, then the mono developers environment opens up, and then I can see the entire script, and here's where I can actually code. Alright, we're not going to touch that just yet. We're going to go back here and click on Cube. Now, I want you to focus on this transform component. So here in the inspector pane, or the inspector area, however you call it, I typically call them panes. Some people call them areas. But in the inspector area, all these are different components. This is the transform component. This is the cube mesh filter component. This is the box collider component. And then you add new stuff by adding components. So the transform shows you your position. Now, why they named it transform, I don't know. I'm sure there's some big technical definition for that. But my position on the x-axis, my position on the y-axis, and my position on the z-axis. So we already talked about that last week. Remember when we made a cube, we kind of moved it around the screen a little bit manually? So in my script, when I'm writing things to say, hey, when I press the A key, I want him to move one space to the left, we're doing that from relationship to the camera. So if the camera's here and this guy's going to move left from the camera's perspective, which way is left from the camera's perspective? Left would be going this way. So if I grab that and move that way, so if I move left, I'm actually moving in the negative x position. So now I'm -3. And if I go to the right, again from the camera's point of view, so if I switch this around, so this is what we're talking about from the camera's point of view. If I go left, you see the numbers adding up in the minus. And if I go right, the numbers are positive. So what that means is, whenever I'm coding, if I want to code, the A button moves me one step to the left, then I need to code and say, hey, I need to go to the transform position X and move him, -1 space whenever I press the A key. Alright, and don't forget, if you're moving around the screen, you can always use your arrow keys, and I'm using the right mouse button and turning and then moving, and right mouse button and then move with the keys, move keys, right mouse button, move keys, right mouse button, move keys, that stuff. And that way you can kind of get around in your scene. So keep that in mind. We move in relationship to, or in relation to the camera. So if I wanted my player to always start right here where he's at now, well, let me move this over a hair. If I wanted him to always start here, I might do, player start position, x equals 0, y equals 0, z equals 0. And Unity even does this better because we don't have to say x equals 0. We can just say player start at 0, 0, 0. And Unity always knows that the numbers you give are position x, y, and z, which is kind of cool. So now I don't even have to say x equals 0. I can just say 0, 0, 0. So writing scripts is kind of that easy as long as you know the names. I can't say player start at 0, 0, 0 because that's a transform component. So I'm going to use the word transform in there somewhere because the transform is going to be 0, 0, 0. So that's how Unity kind of like keeps everything together. So when you say move to this transform position, it knows I'm going to put 0, 0, 0 here in the transform component. And I'm not just restricted to the position, so I could do transform position 0, 0, 0, or I could do transform rotation or transform scale. So as long as I use those words, I can affect anything in that transform component. So by knowing what component you want to affect, you can write the script. So in this case, I'm going to do transform.position because I want to go to transform and then I want to go to this setting in transform. So transform.position 0, 0, 0, and that's going to start me always on that position. Now, if I want the cube to move, I have to tell the computer what the new position is going to be or what direction he's going to move into. So I can't just say, hey, move it from position 0, 0, 0 to position 1, 0, 0. I typically have to say, hey, move in this direction. So whenever we give directions in a 2D or a 3D environment, Unity uses what's called a vector. So if it's a 2D environment, it's going to be a vector 2. If it's a 3D environment, it's going to be a vector 3. And a vector is just two intersecting lines that reveal a 3D position. So if I've got a 3D world and I want to try to figure out my position, I need to have two intersecting lines that intersect at my position, and that tells Unity where I am in relation to the 3 dimensions. So Unity uses the term vector 3 to relay a 3D position. And Unity uses a vector 2 to relay a 2D position. So in other words, with a vector 3, I need to give 3 different variables, x, y, and z. But with a vector 2, I only need to give 2 variables, x and y. So we already mentioned, hey, transform.position, and then I can enter my stuff. So if I did transform.position equals, I'm going to go to a new position, and that new position is going to be 0, 1.3 space 0. This would move it to z0, y, or actually that should be x. I'll need to fix that on the slide. So that's what I do. Transform position to a new vector, and then I give the new position. So I want you, so from wherever you're at, move to this location, or move in this direction, this vector 3. So go back to Unity and double click your player script down here. If it's not there, go to Assets, Scripts, double click Player, and bring up MonoDevelop, and we're actually working on the script. Alright, here's what your script looks like by default in Unity when you start up. And sometimes you'll also see, actually most of the time, you'll also see the fixed update. So let's talk about these. Alright, your first thing is the start, so void start. Anything in void start only runs one time. So that's where I actually put the code to my game. Hey, fire off this thing, fire off this thing, fire off this thing. So the stuff in start only runs one time. Now when I say one time, what I mean, that doesn't mean that you can't have loops, because you can have loops in there that continue to run. But the commands, like if I do, print to the screen, in start, it's only going to happen one time. Now, void update and void fixed updates are two functions that occur every frame. So if I said, have the player say hello here under void update, every frame he would say hello, 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 hello. So it just repeats with every frame. So now then you're asking, well, what's the difference? Well, have you ever played a video game with a frames per second counter? And sometimes your frames per second are 50 or 60, and other times they drop to 20 or 30. So as you're playing a game, the time it takes for your computer to draw a frame can vary greatly. So update is for things that you're okay with that. So update occurs, update is run every frame or checked every frame. So typically in first-person shooters and other games, any kind of movement that is physics-based, a character that can jump and do things like that, you do not want to put those commands in update, because update can sometimes be fast and sometimes be slow depending on the speed of the machine and the graphics and things like that. So every frame, whatever's in update runs. Now fixed update does not run every frame. Fixed update runs at a set interval. So if your frame takes longer to draw, you may get two parts of fixed update to run, if that makes sense. So fixed update is on a fixed schedule. So it's checking it very often and very regularly, where update might not check it regularly because some frames are longer than others. So fixed update is a more uniform way, and that way it's more responsive to player input, and it doesn't vary depending on the machine or how many frames per second are being drawn. So the majority of your time you're making character controllers, you're going to be working in fixed update. But for our thing, because we're not going to apply any physics to this block or anything, we're just going to do our code in update. So just make sure you understand those three sections. Void start, that's where you put the code for the game. And anything in start is only going to run one time. Now, again, that's not counting loops. So whatever's in start runs one time. Anything in update or fixed update runs continuously every frame. Update runs only once per frame, and fixed update runs on a very uniform time scale, so it's very accurate, regardless of computer speed and all that other stuff. So that's typically where we put any movement really that's based on physics or a rigid body and stuff like that, those components, which is typically your players. But again, in this one we're just doing a cube, so we're going to put our code in update. So in the slides, if you see the code in update and you wonder why you did that, it's because we're not applying any physics, and I just did it for because I just wanted to pop it out real quick and I didn't add the fixed update thing. And another reason I used update is because I want to get into delta time. And delta time is a way to kind of bring update to mimic fixed update. So if I don't have fixed update, and I want my stuff to happen at regular intervals, I can use a setting called delta time. And delta time just says, hey, whatever this command is that includes delta time, so it's just the command. So let's say I have a command here, and a command there, and a command there. So I got a bunch of different lines of code. The line of code that has the word delta time in it, only that line of code is affected. And delta time says, hey, don't go off of every frame rate. Go by a fixed point in time, which really brings it to act just like a fixed update. Alright, if for some reason you're totally confused, like I am, email me, and I'll try to. Sometimes I guess I write better than I talk. Alright, so I want you to put the following code here underneath the update. So you're going to do transform. And remember, if these come up, you can just hit tab and it'll finish the line for you. So transform dot, and then we're going to translate. So remember, I can hit tab, that'll finish the word for me as long as the IntelliThing has the right word highlighted. And then we're going to use one frame times time dot delta time. Comma. Then we're going to do 0, and then we're going to do 0, comma. So I have transform dot translate, and then I have in parentheses 1F or move one frame in the X position and move every time a time segment kicks off, and then don't move any spaces in the Y or the Z axis. So remember, as long as we do transform, we're saying, hey, in the transform window, do this and move me in the X, Y, and Z. So this is going to move me in the X, and this is going to move me in the Y and the Z. So in the Y and the Z, I'm not moving because I said 0. So 0 frames. Don't move me. But in the X frame, move me 1. So now go up here and hit File, and then Save, and then close that. And then hopefully, if I click on Play, So just to reiterate in case you missed this, because something got messed up there. If you haven't, grab the player, the script that you did, and drag it onto Cube, and then change your camera or your scene to perspective or ISO, and then hit play. And you can kind of see your cube. And actually, you don't even have to change that. You'll still see the exact same thing. Hooray! Now, you can also adjust your camera. Like if I move the camera up, maybe that'll change my... Oh, it just makes it... You just move the camera up. Okay. So don't listen to me about that. So all of you now should be able to watch or to be able to move something across the screen and make it continuously move. So, and then you understand that either update or fixed update is where that goes in the script. Now another thing you can do, you can just grab the game window and move it down here or somewhere else, and then when you hit play, you can still see it moving up here. Ooh, sorry, something on my video got funked up again. I don't know what's going on. But I don't know if you saw that, so I grabbed the game tab here from there. I just dragged it down. And then this is what you're going to see if you're in the game. But then from the isometric view or the perspective, I can click here and I can kind of see my cube move. It's easier to move the cube around from this perspective than it is to do it from this perspective at this current time. So I'm just going to leave this stuff like that for now. Now, if anytime we're doing something, you pause the video and you're like, oh crap, what was it? What the heck did time delta time do? I can go to my script and I can click on this little book here under the inspector, and that'll bring up the documentation. And then from here I can really look for, oh, crap, what was he talking about? Oh, delta time. And boom, so here's time delta time. And it describes it, the time in seconds it took to complete the last frame. Use this function to make your game frame rate independent. So we don't want to rely on the frame rate. We want everything on a fixed time scale. So it's automatically called, from inside fixed update, because fixed update runs on a set time scale, where update runs based on the frame. So remember, frames can run at different times. So we typically want things more focused on time than frames. Now, to set starting positions and things like that, update is great. But for everything else, we typically want to do fixed update. So that's how you can look and find different information if you're looking for it. So anytime you're in Unity and you don't know what something does, there's typically this little book, and you can click that, open it up, and it'll open up to that corresponding part in the documentation, and then you can search the documentation for that information. Alright, so just a quick breakdown. When we did transform translate, and then we did our stuff, we're saying use the transform component and translate its position to something new. And then we did 1, 0, 0. So we said every time the timer hits, whatever that unit of time is, milliseconds, microseconds, whatever, move me one space in the x-axis. And then delta time just means adjust its new position every frame or every set unit of time. And that's why the cube moves nice and smooth, one frame over each time segment. So we get that nice, cool, smooth movement. Now if it was based on frames and I had something else going on in the background, some frames happen again faster and slower than others. If I got more stuff on the screen, it takes more times to draw the frames. So the frame time is longer. So then I get stuttering and some other weird stuff. And we typically don't want that. Alright, so now I go back to your script. Open that up. and we're going to take out this line of code that we put in. And we're going to go up here to start, and we're going to say transform.position, give it a new vector 3, and remember, so now we need to give it the new position, so it's going to be 0f, and then it's going to be 1.3f for the y. And you can even see here as it comes up, like you're seeing the y. Like I know this second value is the y position. Now remember, y is like the up and down. So the middle of our cube is where it points to. So we need to move the middle of the cube up so that we can see the entire cube in the screen. And then I need to go to the z-axis, and you can see now it says, hey, now I'm going to do the z. So we're going to do 0, so 0 frames. So transform position. So this is going to say, hey, create the position here. So then save that. Close that. Now I'm going to move my cube. Now I want to show you real quick. If I look at where the cube is in the directions. So right now the y is at 0.55. If I put this all at 0, we see the cube is in the ground. So I need to bring the cube up so I can see it. So typically, ooh, I did 1.3. So our cube is going to be up here a little bit higher. So I probably should have done 0.5. So let's go back to our script. And let's make this 0.5. 0.5. And close that. Yeah. Now I'm going to move my cube on the z-axis and move it over here. Now if I hit play, start's going to move it back to that starting location one time. So transform position says, where do you want me to position the object? Where transform translate is used for moving objects continuously. So now you know a little bit about positioning. So let's talk about, or let's go to using the keys and adding keyboard controller movement. So go back and open your script. And I'm going to actually, I can leave that because that way every time my cube will always start in the same position. So go back to update. Remember, if we're doing some kind of movement with keys and stuff where I'm going to keep pressing the keys, I need to do under update or fixed update. If it's going to have physics are going to apply to it for jumping, things like that, I want to do it under fixed update. But in this example, we'll just do update. So what's the first word I'm going to use here for my command? Alright, so if you said transform, you're right. Hooray! And then I'm probably going to do translate, and I'm probably going to have a vector 3. But what else am I going to kind of pop in there? So sometimes, especially if you're scripting and you're new to scripting, it helps if you say something out in English. So in the simplest form, what are you trying to do? And I want to move the cube along an axis when I press the arrow key. Well, what's the axis called? Well, let's go take a look. Now, this time don't shut this down, just minimize it. But if we go up here into our game, I left it on. Don't be like me. If I go under Edit, and then, oh, not Snap Settings, Project Settings, I get the Input Manager. Now, the Input Manager has information that's already built in to all the different axes. So if I go to the horizontal axes, I can see that the left and right arrow button and the A and D key are already mapped to the left and right movement. Yay! And the name of that is horizontal. So I now know that the x-axis is named horizontal. So as long as I use the word horizontal, I know it corresponds to the x-axis. So I can use the word horizontal in my scripting. And I don't have to do any mapping of the keys or anything because that's already done for me. So bring back up your Unity script. And now, I'm actually going to drop this down line so you can kind of see it. We're going to do a transform translate. Transform dot translate. And now in parentheses, we're going to do a vector 3 dot right, because we're going to move our guy to the right, times. Now, in order to access the input manager, we use the word input dot get axes. So it's just input dot, and then it's get axes. So anytime you're going to do movement and you want to use the input manager where it already has the keys mapped, you do input.getAxis, which sounds pretty simple. We want to use the input manager and we want to grab a specific axis. And then you just give it the name of the axis you want to do. Well, I want to grab the horizontal. The horizontal axis. Alright, did I spell that right? Because I typically do that. And then this one gets 2 apostrophes, semicolon. I'm sorry, I said apostrophe. I meant parentheses. Obviously, English is not my favorite method of communication. So transform translate. Hey, I want to go to the transform box and I want to translate its position. I want to give it a new position. And it's going to be a vector 3. And I want to use the input manager and I'm going to apply it to the horizontal axes. So now I can move right using the horizontal axes. But now remember, every time you move right, if I move right in a negative fashion, I move left. So let's see how this works. So transform translate, vector 3 times input axes, data. So make sure you save that. So this is just saying anytime I hit the horizontal button, move me in this direction. So if I minimize that now and I hit play, I should be able to hit the A key, whoa, and move my guy. So A and D now, woo, ray, we now have movement. So whoa, trigger, we need to slow that back down a bit. So let's go into our script. So we need to go into our script and we need to make some changes. So if I go to cube and I look at my script now, my script only has one option, and that's where I put in a script, because my script isn't asking for other variables. So what we're going to do is we're going to go back into our script and we're going to create a variable for player speed. And then once we create that variable, it'll actually show up here, so then we can manipulate it in Unity without having to go to MonoDevelop, which is kind of cool. So at this point, I'm going to have you open up your script again. And we're going to add 2 lines of code. First, above start, right here under public class, you're going to create a public variable. Any public variables, any variables that you can use anywhere in the game or anywhere in your script, so I can use it in start, update. Remember, stuff that I create in update only stays in update. Stuff I do in start can go different places, but you get the idea. So anything up here can go anywhere down here. So anytime I'm having specific variables that apply to the entire game, like my player speed, I'd want to create those as public variables. So public float. Remember, a float is just having a decimal point in your numbers. Some programming languages call it double. And then we're going to do player speed equals, and we're going to say 5.0 per frame, and semicolon. Alright, now we're going to go back to our script here, and we're going to jump in right there between those parentheses and say times player speed. Alright, so once I add that line to the script, I can save. So you should have added this public float, and then you should have put the times player speed. So now I'm going to move times the player speed. So again, make sure you save, minimize that, and then if you look and let this update, alright, there it is, boom. So now player speed has its own variable. So now I can hit play, and I'm like, whoa, slow down there, Nelly. And I can say, hey, let's make my player speed 2. And then hit play. Alright, that's still kind of fast. We're going to have to slow that down a bit. 1. Woo! Ooh, alright, that's pretty good. I can live with that. That's still a little touchy. I might even go into negative numbers anyway. So, but you get the idea. So it's that simple. So again, that's still a little fast. So what we can do is we can go back up to that line and we can add delta time to it. So players times player speed times, and it's always time dot delta time. And then again, that'll take it off of the frames per second, which in my case, my PC is very fast, and it'll put it more on a standard fixed time. So then if I hit File, Save, Minimize, and then hit Play, now obviously I'm crazy slow because I did it by time. So if I go back to 5, make sure you turn this off because you can see I turned it to 5. If this game is on and you make changes here and you turn the game off, those changes do not stay. So don't be an idiot like me. Ah. Really? Now that's too slow. Alright, I can live with that. Yay! I got some movement. Alright, so pause the video, play with that a little bit, find a player speed that you think works for you and your machine. Remember, every computer is different, and this is why it's so hard to code for computers and so easy to code for console games. This is why there will always be more console games out there, because it's so much easier writing a game for a console than it is for a computer. Because some people have crappy Dell machines that run at 3 frames per second, and other people have really cool gaming rigs that they built themselves that run at 70 frames per second. But you can see there's ways around there, and using time delta time is one of the ways around that. So now we need to add the next axis of movement. We need to now work on the y-axis. So let's go find the name of that. So edit, project settings, input, and close horizontal and go to vertical. And hey, there's my, why does it say x-axis? I need to punch that. But so vertical is just going to be called vertical. Well, that's pretty easy. So now I can go back to my script, and now let's add the line for our vertical movement. Now there are a couple ways to do this. Some people would just add the new stuff to the end of this line. So I got this big line of code. I could modify this, or I could just go down here and I can actually copy this entire thing and then go and paste it and then change this to vertical. And I sure hope I spelled, no, of course I did not. Vertical. Make sure you spell it exactly like it is in the input manager. So remember, file, project settings, input, and I go to, hey, it's VERTICAL. I go back to my VERTICAL. So now I'm all good. So that's one way to do it. I could also, I'm going to kill this. I could also modify this by removing the vector 3. So transform translate, and then input axis, and then horizontal, times player speed, times delta, and then if I get rid of that, funk that, I'm just going to go with this. There's a picture in the slide where you can see, and let me show that real quick though. So here's how you could have modified it. So I could have taken that stuff off and then, input axis horizontal times player speed times time delta, and that would have been my x-axis. And then for my y-axis, I could have put nothing. And then I could have put input vertical for, and I put z. That is totally incorrect. This should have went over here with the y. But I could have made it all just one giant line of code by putting horizontal for x, vertical for y, and then nothing for z. I could have put the 0 under z. Alright, and if you tried this, you found out it doesn't work because I said right. So I can't have two commands that do the exact same thing. So I'm just going to wipe this out, and I'm going to do the line that I have with the combined thing, and I'll pause the video and I'll be right back. Alright, so here's my line of code, and I was actually incorrect when I was showing you the slide. So the slide is correct. So x, y, and z axis. So for the x axis, I'm going to move on the horizontal plane, And then on the z-axis, I'm going to move on the vertical plane. So let me show you that real quick. The z-axis is actually this way. So if I go to the cube, this is the z-axis. So that's what I want to do. I want to move these two directions because I just want to move on the plane. So I don't want to use y. Remember, y is green. I don't want to use y. I want to use x and z. So that's why this is correct. So you can see kind of how confusing some of this stuff can be, which is why I wanted to break this chapter down into two different sections. So this week we'll talk about these basics, and then next week we'll get into the actual script for our game, which actually gets a little bit more complicated. So your script should look like this, and this is exactly like what's on the the slides. And if you save this, and I hit File, Save, so mine's already saved, I can hit play, and now my cube should be able to move around. Hooray! But I think I have the keys a little bit backward. The left and right work okay. It's the up and down that look a little bit different for me. But if I move it around, up. Alright, really? Come on. Yeah, now that works a little bit better for me. Now I can control it better because I'm going to do it from the camera's point of view. And I don't know why, but for some reason once you move the camera it kind of dies. So turn that off. Whoop. Ah, you little. Yeah, now I can move nice and smooth. So I'll load this script up, and just in case you couldn't see it, I'll just make it a text file that you kind of cut and paste this into yours. If for some reason you couldn't see this in the YouTube video, because I know sometimes the coding like this is hard to see on the screen. But don't forget that stuff is also in the slides. But you should now be able to move your stuff around the screen all nice and neat. So now I guess you understand the basics of player movement. So now we can next week we can jump into making our character on the screen move. So at this point, if you have any questions, make sure you email me and let me know. Your project, actually you have two projects this week. You're actually going to go to the Unity site and you're going to create the Rollerball game. Let me show you that real quick. So if you just go to the Unity site and hit Learn, Tutorials, you're going to make the Rollerball, which is a really simple game. All these videos are only 10 minutes or less. Actually, I think some of them are like 5 and 6 minutes. So you can make this easily in less than 2 hours. So you're going to do this, and that's going to be a project you're going to turn in. And then you're also going to turn in this project where I can just open it up and I can hit play. And I can move your stuff around so that I know that you did it. So when you submit this stuff, just go to the Unity project folder. So on your PC, find wherever you installed Unity at. So in my case, my Unity is on my E drive under Unity, and then find the project folder, and then this one's called Trash Me, which I don't know why it's down there, probably because I haven't saved the project yet. Make sure you do File, Save Scene, and you call it, Test, and then File, Save Project. And then hopefully it'll show up. So just find the folder that it is, right click, and zip that sucker, add to archive, and drop me the zip file. You cannot give me just the whole folder or anything like that. Angel will funk that all up and I won't be able to open it, in which case you'll get a big goose egg, also known as a 0. And you don't want that. So find where you install Unity, go to the project folder, and then zip the one project, the one specific project for the Dropbox. Do not zip your entire project folder. And I open it up, and all of a sudden I see 14 projects, and they're all named Trash Me, and I'm like, oh God, which one did he want me to open? Because that will also result in a big fat 0. So any questions, let me know. And again, I will copy this script and put it in your materials folder for this week in case you couldn't see that stuff. So have a good one, and email me if you got questions.